All right, here's where we left off last time. We had started discussing ions. Losers on the left, nonmetals gain electron, metals lose electrons. All right, gaining electrons is fairly straightforward. You fill the shell or subshell. Well, the nonmetals are so close to the right, it's a matter of filling the shell. Losing electrons, the metals tend to lose their s electrons first, then either their p or their d electrons. It's either or, because if you don't have a filled d subshell, then you don't have p electrons, and all you're going to lose is d. If you do have a full d subshell, then you're not going to lose those. A full d subshell is full of resonance. It's very, very happy. So the alkali metals and the alkaline earth metals, those are the two columns over here on the left. The alkali are the first column. Alkaline earth are the second column. All they have is s electrons, and that's what they'll lose. So the first column goes 1+, second column goes 2+. The transition metals will lose their s electrons, and then possibly some of their d electrons. Okay. So, for example, scandium, very first transition metal, can take a 2+ charge or a 3+ charge. So, scandium there we go. Scandium is argon, 4s2, 3d1. So it can form either scandium 2+, in which case it loses both of its s electrons, leaving it with just a d electron, or it can form scandium 3+, in which case it also loses its d electron. Okay, now let's look at iron. Iron's a popular one, number 26. Iron, argon, 4s2, 3d6. Can form either a 2+ ion, which it does by losing its s electrons, leaving it with its 6d electrons, or it can form a 3+ ion by losing one of its d electrons as well. That leaves it with a half-full subshell, lots of resonance, very happy, and those are the ions that iron forms. Now let's hop on over to the post-transition metals. Let's take a look at tin. Okay, number 50, way over here. Okay. Tin is in the fifth column, or in the fifth row, and it's preceded by krypton. So, tin's neutral configuration is krypton, 5s2, 4d10, 5p2. Now, this D subshell is full. It's not going to do anything. It's got so much resonance, it's perfectly happy. Now, the first thing it can form is a 2+ ion by losing its s electrons, leaving it with 4d10, 5p2. The other ion that tin can form is a 4+ ion, which it does by losing its 5p electrons as well. Now let's go ahead and look at silver. Silver is element number 47 here in the middle of the periodic table, fifth row, preceded by krypton. So silver is krypton, 5s2, 4d9. Except if you put that answer on the test, you'd get it wrong, because it's not 5s2, 4d9, it's 5s1, 4d10. which means that silver only forms a single ion, so 1+ ion. It forms by losing its s electron, leaving it with a full d subshell. And similarly, we can look at zinc. Zinc is one up and one right. It is right here. Element number 30. Zinc, argon, 3s, 4s2, 3d10. Now think about what kind of ion it wants to form. First, it's going to lose its s electrons, so one ion it can form is 2+. So it's argon, 3d10. And then it doesn't have any p electrons to lose, and it does have a full d subshell. So zinc only forms the 2+ ion. Then we can look at aluminum. Aluminum is neon, 3s2, 3p1. It's one up and one right from zinc. It's element number 13. It has no d electrons. All it can lose is s and p. And aluminum is slightly different. It's another sort of exception in that it only forms the one ion by losing all 3 of its electrons at once. So silver, zinc, and aluminum are special metals. Okay? They are not alkali or alkaline earth, but they only form a single ion. Silver 1+, zinc 2+, aluminum 3+. And when you look at the periodic table, you'll see silver, zinc, aluminum, all in a diagonal there. So if you're a very visual person, that might help you remember that. If you want a mnemonic, we have AZA, so Alice's Zany Adventure. Not particularly zany because it just forms a single ion, each 1+, 2+, 3+. All right, so by looking at the s, p, and d electrons, you can see some of the ions that various things form, and you'll have an idea of what is possible. I will tend, however, not to ask you too much about the transition metals because they can get very complex and nasty. Like manganese and chromium here in the middle. Chromium can form anything from 2+ to 6+, manganese anything from 2+ to 7+. They're happy to lose any and all of their s and d electrons. Yes, even though manganese has a half-full shell, it will form a 7+ ion. And that's, a violation of the rule I told you. So, all right. Now we look at ionic radius. Okay, that is to say, what happens to the radius of the atom when you gain or lose electrons. It's simple. When you lose electrons, the nucleus is able to pull tighter on the electrons that remain, so the ion is going to get smaller. If you gain electrons, then those negative charges repel one another. They're pushing at each other, and the ion is going to get bigger. So, you draw it out. Okay. If you go from neutral, 0 charge, to, by gaining electrons, you're going to get a negative charge, and you're going to get bigger. If you lose electrons, you're going to get a positive charge, and you're going to be smaller. Depending on how many electrons you lose and whether or not you're going up or down a shell, that will change how much the size changes. But you will know that, generally speaking, positive ions are smaller, and negative ions are bigger. But you can also compare what's known as an isoelectronic series. Okay? So an isoelectronic series means iso means it's all the same, electronic, electrons. So isoelectronic means they all have the same number of electrons. Okay, so you look at magnesium 2+, sodium 1+, neon, fluoride, oxide, and nitride. Okay. So if you look at the periodic table, you'll see magnesium's here at number 12, sodium number 11, then neon, fluorine, oxygen, and nitrogen. So they're all in a row, going from element 7 to element 12. So that's our isoelectronic series. And you draw them out. You have magnesium 2 plus, sodium 1 plus, neon, fluoride, oxide, and nitride. They are all going to have the same number of electrons as neon, so 10 electrons. But they're still that element, even though they're ions of the element, so they have different numbers of protons. So you have 12 protons, 11 protons, 10, 9, 8, 7 protons. Okay? So the more protons you have, the harder you can pull on the electrons around you. Okay? Another way of looking at it is these guys are positive ions, these guys are negative ions. Positive ions are getting smaller, negative ions are getting bigger. Okay? So this is the smallest ion of that series, and this is the biggest. Okay? So there you go. And that is it for our periodic trends. That does it for this series of lectures. I hope you have a pleasant evening.